Welcome. In this video, we're going to prove that points A negative, prove or disprove that points A negative 2, 2, B 4, 2, and C 1, 6 form an isosceles triangle. So first thing that we will do is graph the triangle. Right, so we have the points negative 2, 2, 4, 2, and 1, 6. And let's write down what we need to show. All right, so if we want to show that it forms an isosceles triangle, we're going to show that two sides are congruent. My equals is all wavy. Right, so this is what we're going to show because this is hopefully an isosceles triangle. What would have to be true for this to be an equilateral triangle? If this were an equilateral triangle, then all three sides would be congruent. I forgot to label the triangle here. This was A, B, and C. So for this triangle, that would mean that AB was congruent to BC, CB, doesn't matter which way I write it, CB is congruent to CA. All three sides would have to be congruent. So we know what we have to show. Now we need our work. Or actually, excuse me, now we need our formula. That's the step 3. Show is the what do you need to show? Because we only want to do the work that's going to show what it is we're trying to prove. And the formula is going to tell us what work we need to do. All right, so if we're looking to prove sides congruent, that's the distance formula. Come on. All right, I guess that's good enough. All right, that's good enough. All right, so there's our distance formula, difference in the x-coordinate squared plus the difference in the y-coordinate squared, then we simplify the radical, and then we need our work. All right, so we'll find all three sides. All right, so AB would be negative 2 minus 4 squared plus 2 minus 2 squared. All right, well, that's going to be negative 2 minus 4 is negative 6. 2 minus 2 is 0. And then negative 6 squared is the square root of 36, which is 6. Oops. Oh, I hate when that happens. Move over. Oops, too far. Just right. All right, so now let's find the next side. We'll find CB. All right, so that would be 4 minus 1 squared plus 2 minus 6 squared. So that's going to be 4 minus 1 would be 3 squared plus 2 minus 4 is negative, or 2 minus 6 is negative 4 squared, which is 9 plus 16, which is the square root of 25, which is 5. And then our last side, which is CA. So CA would be negative 2 minus 1 squared plus, and since I started with negative 2, I'm going to start with 2. 2 minus 6 squared, which would be square root of negative 3 squared plus negative 4 squared. And then we square. So that would be 9 plus 16, right? Because when we square, it becomes positive, which is the square root of 25, which is 5. All right, and we can see we have, so this is definitely not equilateral. All three sides aren't congruent. But it definitely is isosceles, because two sides are congruent. So now we're going to do this proof as a paragraph proof, and it is a mighty short paragraph proof. It's like 2 sentences. All right, so since CB is congruent to CA, and let's put the measurements in there. CB equals 5, and CA equals 5, using the distance formula. Sometimes I forget to write the formulas in when I do the paragraph proofs. Try to remember. So since CB is congruent to CA, and we have the numbers there, and why, CB equals 5, CA equals 5 using the distance formula, triangle ABC is an isosceles triangle. And we know an isosceles triangle. Actually, let's make this all this part one sentence here. All right, so triangle ABC is an isosceles triangle since it has 2 congruent sides. That's all we need, right? We just have to find the measurements of the sides, and then when we justify, you don't have to justify it's a triangle, it's got 3 sides, right? You just have to show that it has 2 congruent sides, and how do you know? You use the distance formula, and you found the measurements of the sides. Therefore, it's an isosceles triangle because it has 2 congruent sides. All right, that's the end of this proof. This one was a short one. We'll do another triangle proof coming up next. Bye for now.